Hello everyone, welcome back to our channel. So, it is a kickstart to the MSc Statistics syllabus. So, in the yesterday we have started the third paper, Probability and Applied Probability Theory. So, today we are going to start the new paper, which is Mathematical Analysis, paper 1. So, we will see this paper and we will both continue this paper and the third paper. The video will be released day after a day. So you will have a 1 day to watch the video. And we'll see the first unit. It is in the first semester and metric spaces. These the mathematical analysis video classes are applicable for both pure and applied statistics. So first we will learn about what is a metric space. Let X be a non-empty set where elements are called as points is said to be a metric space. So let us learn the definition, learn line by line. Let X be a non-empty set. Do you know what is a non-empty set? First, okay. Let us take the X and Y. These all belongs to the real number system. Real numbers are nothing but which includes integers, natural numbers, whole numbers, and rational numbers and irrational numbers. I think you know about the real numbers. Now let us take X and Y. X contains some elements in it. For suppose 1, 2. And Y does not contain anything. Let us say it does not contain anything, which is nothing but X has something in it, so we won't call X as empty set. Which has something elements in it, we say that X is a non-empty set. Y is equals to nothing. There are no elements in it. So we can call it as Y is a non-empty set. For easy one, I am giving the another example for you. Let us think you have a box. This is one box and this is the another box. And in one box you have some things in it. For example, let us think these are the 3 things you have in a box. In one box you don't have anything. If your mama said to bring you an empty box which has nothing in it, then will you take this box to your mom or this box? Absolutely, your mama asking to get the empty box, which is nothing but which does not contain anything, so that your mama can put something in it. So you will go and give this box to your mama, which is nothing but the empty set. If you take this box and go to your mama, and if you give, your mama will say that I said you to bring the empty box which does not contain anything in it, right? So which is nothing but this is non-empty set. I hope it's clear what is an empty set and non-empty set. Which has something else in it is called as non-empty, which doesn't have anything is called as an empty set. Okay. Where elements are called as points is said to be a metric space. Now only we have seen that in one box we have seen some things like this. So these are called as elements. These are called as elements. These elements are nothing but points is said to be a metric space, where x is equals to 1, 2, x contains elements. So these elements 1, 2 are called as points. Okay. If with any 2 points p, q belongs to x, there is associated a real number, that is dp, q is called as a distance or metric form p to q, which is nothing but if we take 2 points, any 2 points. Let us consider any 2 points here. This is a box you have, and you are taking the 2 points p and q. Therefore, p is here and q is here. This p, q belongs to x. This x belongs to the real numbers. I am clearly said that what is the real numbers. Then the distance between p and q, d is nothing but the distance. Here the distance between p, q is called as distance or metric form p to q. It is called as metric form or distance from p to q such that if it satisfies the given following 4 conditions. ఇప్పుడు ఒక 2 points అనేటివి తీసుకుంటే, which is nothing but p and q, and this p and q belongs to the real number system, and the distance between p, q is called as a metric space if and if only it satisfies the given following 4 conditions. So the first condition is dp, q should be greater than or equals to 0. For all p, q belongs to x, it is a positive property. The first property is the positive property. Positive is nothing but which cannot be negative. So the distance between p, q should be greater than or equals to 0. And the second condition, dp, q is equals to 0 if p is equals to q. The distance when the distance between 2 points will become 0. If p is equals to q, then the distance will be 0. For example, I think no need to explain the example. You can easily understand. If p is equals to 2 and q is also 2, let me write here. If p is equals to 2 and q is also 2, then the distance between 2 points, how the distance is calculated? Under root x2 minus x1 whole square, which is nothing but 2 minus 2 whole square, which is equals to 0. That's why only here mentioned that dp, q is equals to 0 if p is equals to q. This is the null property. And the third condition, dp, q is equals to dq, p, which is the symmetric property. Third one, symmetric is nothing but the data will fall equally on both sides. డేటా అనేది ఈక్వల్ పార్ట్స్ గా ఈక్వల్ పార్ట్స్ గా డివైడ్ అయితే కనుక సిమెట్రీ అని అంటారు. ఫర్ ఎగ్జాంపుల్, ఇఫ్ యు టేక్ దిస్ ఇస్ ఎ let us take this is a graph and you have some data points. This is the mean. This is the mean we can take. If the data points are equally distributed over the left side and over the right side, if you have for example, if you have 8 data points and in the left side you have 4 data points and in the right side you have 4 data points, which is nothing but the data is distributed equally on both sides. That's why only the symmetric property is dp, q is equals to dq, p. If you learn the concept in this way, you no need to by heart it. And the fourth condition is dp comma q is less than or equals to dp comma r plus dr comma q. This is the inequality or triangular property. If you see any of the inequalities theorem, the sign will be less than or equals to or greater than or equals to. And here how we came r is we are adding some integer to the distance. So this will be clear when we do a problem. So the summary is, when we take X is a non-empty set and elements in the X are called as points, is said to be the metric space. And if you take any two points that belongs to the real number system and the distance between P comma Q is denoted as TP comma Q, if it satisfies the following four properties: positive, null, symmetric, inequality, then it is called as a metric space. I hope it is quite crisp clear about what is metric space. Now we are going to see the problem. Example, for any x comma y belongs to the real number system, dx comma y is equals to mod x minus y. Show that D is a metric space on R. సో ఇక్కడ ఏమంటున్నారు, మనకి dx comma y అనేది mod x minus y అని ఇచ్చారు. సో ఈ డిస్టెన్స్ ఈ d అనేది మెట్రిక్ స్పేస్ ఆన్ R అని చూపియాలి. And the given information, first for any problem we need to write what is given and what we need to find out. The given information is x comma y belongs to R. And d of x comma y is equals to mod x minus y. So now we need to prove D is a metric space on R. D is metric space on R. So first we need to write what is the given part and what we need to find out. Then we know that in order to any point to be satisfied as a metric space, show that D is a metric space. Then we need to satisfy the four properties that we learned. The four properties is, first one, which is the positive property, which is nothing but positive means always greater than or equals to 0. So d of x comma y is greater than or equals to 0. Here mod x minus y, whenever you have a mod, it will always be greater than or equals to 0. For example, if you take x as 3 and y has 5, which is 3 minus 5. 3 minus 5 is nothing but minus 2. We have mod, then it will become 2. 2 is always greater than or equals to 0. So the first condition is satisfied. So the first condition is satisfied. Now we need to check the second condition. The second condition is null property. Null property is nothing but dx comma y is equals to 0 if x is equals to y. Right? It is equals to y. If you take x value has 2 and y value has also 2, then 2 minus 2 is 0. Here the condition is there. If in null property, if x is equals to y, then d of x comma y is equals to 0. So I have taken x and y value has 2. Then 2 minus 2 is equals to 0. The second property is also satisfied. Now we need to check the remaining conditions. The third property. The third property is What is the third property? It is symmetric property, which is nothing but dx comma y should be equals to dy comma x. So if we write x comma y has y comma x, is there any problem? Because we had mod here. There is a mod here, applied mod here. If we write x minus y also, y minus x also, it is same. Because we have the mod function. So anything that becomes minus, it will become the plus. Let us take an example. And we take the x value has something 6 and y value has 3. Therefore, mod x minus is 6 minus 3, which is equals to, we get mod x minus y is equals to 3. And mod y minus x. Y is 3. 3 minus 6, which is equals, there is a mod, and we get minus 3. Mod minus 3 will become 3 only. Then mod x minus y is equals to mod y minus x, which is nothing but 3 is equals to 3. So the third condition also satisfied. Now we need to check the last condition. The last condition is triangular or inequality property, which is nothing but dx comma y should be less than or equals to d of x comma r plus r comma d of r comma y. Okay. Here r is, we can take any integer, natural numbers, whole numbers, rational numbers or irrational numbers which should belongs to the real number system. So if I add r as, ఇక్కడ r కి బదులు నేను ఏమని తీసుకుంటున్నానంటే z అని తీసుకుంటున్నాను. So I'm adding this z and subtracting this z in this equation. Therefore we get mod x minus z and plus z. I'm adding and subtracting. Therefore minus y. And now I am separating the mod, which is nothing but x minus z mod plus z minus y. Z minus y. And here we added z minus y. So if you take here x minus y is equals to d of x comma y. So x minus z, I can write it as d of x comma z, right? D of x comma z. And here d of z minus y, which is in the form of mod x minus y. So I can write mod z minus y has d of z comma y. So plus d of z comma y. Therefore d of x comma y is less than or equals to d of x comma z and d of z comma y. If you see the triangular or inequality property, that d of x comma y should be less than or equals to d of x comma r plus d of r comma y, which is in the same form, right? So now the fourth property is also satisfied. So the fourth property is also satisfied, and the x comma y belongs to R, and d of x comma y is equals to mod x minus y. If in order to prove D is a metric space, we need to prove all the four properties should be satisfied. The first, second, third, and fourth properties satisfied. So therefore, d of x comma y is equals to mod x minus y is metric on R. I hope you have understood this video. If you like the content, please do hit the like button, which makes me more boost and energy to make the videos. And thank you all. Happy learning to you.